Let's start for today, the second lecture of Daron Acemoglu about state formation and the role of the state. I must say I'm very glad that we have these lectures. After all, we do public finance here in these rooms primarily, and the role of the state, of course, is in the center of our attention. And also German ordoliberalism, which in recent years has been cited frequently, is based on the idea of having a strong state which sets the institutional framework for economic activity. It was more a theoretical consideration in the past, but now we hear more empirical results on this phenomena. We are eager to listen to you.
Thanks, Hans Werner. Thanks, everybody, for being here. It's a great pleasure to continue. So actually, today's lecture will touch on both themes that Hans Werner anticipated. So I'm going to talk a little bit about the institutional order, a little bit on the theory side, and then I'll talk about the more direct link to public finance, both theory and empirics today. But the price of that, and I apologize in advance, and give a chance to people to leave if they want to. This is going to be far more technical than yesterday. So, so given both the nature of the stuff, because it's much more, frontier research, and also I'm going to advance a little bit more rapidly, but that's the price. Where do I go? Okay, there. So the as I sort of mentioned. We discussed by the way, sorry. You should please feel free to ask questions. This is no longer a big room, so it's intimate, so please do ask questions. If I don't get any questions, then I will conclude that you're all so bored and I'll have to change topics or something.
But for technical reasons, you have to wait for the microphone.
Okay. All right. There is some order, institutional. And the keeper of the order. So we'll see. We'll model that. So we talked about that, but we took it for granted that the state capacity, at least on some dimensions, can emerge and work. But how does that really take place? For example, why is it that it is better, or is it really better, to have the state enforce laws than community itself? After all, perhaps in this room we don't need the heavy hand of the state, and there is no police officer so far as I can see, but I don't expect anybody to start throwing tomatoes. So there is probably some order here that doesn't quite require the state. Or does it? Perhaps if there wasn't the state in the background, perhaps people would have thrown tomatoes. I don't know. So that's a sort of an inquiry that we need to engage in to some degree. So that's what I'm going to talk about in the first half of the paper, of the talk, which is based on a recent paper I have written, working paper with Alex Wolitsky. So that's going to be entirely theoretical, but hopefully with some insights on the questions that we've started asking yesterday and some of the issues that are on the table. The second part is going to be theory and empirics. The theory is really laying the way for the empirics, so it's really a much more empirical but structural sort of empirical work. So it's going to be based on a recent paper of mine with Camilo Garcia Jimeno, who is at the University of Pennsylvania, and James Robinson. This is actually a recently published paper in the American Economic Review, but since it's so related to what I want to talk about and brings an entirely different set of issues, I thought it was a good idea to sort of bring that into the fold. Tomorrow I will talk about even more preliminary work in progress than what I'm talking about today, but half of today will be on this stuff. So the part one, what is the question? So essentially the question is to some degree the one that I asked. When is it that it's better and it is an equilibrium for the centralized enforcement to emerge? So in other words, we took it for granted yesterday that at least once things become sufficiently complex, we don't want to rely on just the community to do the enforcement, either through social norms, like the TIV that whom we talked about we're doing, or through ostracism, or through cessation of cooperation of different sorts. And instead, it was more, quote-unquote, effective for there to be a state, and that state to lay down the institutions and the rules, and those rules do the enforcement. Is that so? Could that be an equilibrium? What are the trade-offs? So that's what we're going to talk about. In particular, what Alex and I do is we consider a general model, a repeated game model, but you're going to see that the parts that I'm going to present at least are not too complicated. The proofs are, but I'm not going to go through the proofs. Where it embeds two extreme cases, or at least two extreme cases. One is a model, and I'll comment on this in the context of the model also, but a structure that was pioneered in economics by Michi Konduri, and then later by Glenn Ellison and others applied and developed in different directions, which is a community enforcement model, whereby instead of the state or some outsider enforced order, or instead of what we know in Prisoner's Dilemma, where Susanna and I are playing a game continuously. So I know she's my partner, and she knows I'm going to be her trade partner in the future. We have a community, a finite-sized community, and individuals match with each other, and the community tries to maintain some order. And the difficulty is that the community may not know what else goes on in here. So it might well be that actually, Hans-Werner Sinn gets cheated on by Klaus, but, I don't observe that. And how do we sort of make sure that Klaus gets punished? And the solution that, Kanduri came up with is that we can have the following contagion strategies, which is that once Klaus cheats on Hans-Werner Sinn, Hans-Werner Sinn now goes into an infected state, meaning that he now loses his trust in society. You see other people throw litter into the street. You say, oh, everybody's throwing litter into the street, so he starts throwing. So then this bad behavior follows a contagion path in society, poisoning everybody. Now, you could do something more sophisticated, and we do that in the paper, but I'm not going to talk about it. We could also allow some ostracism. Perhaps we get some additional signals about Klaus, we can ostracize him, etc. But I'm just on the Kanduri benchmark. There are prominent examples of societies that function that way. One that received a lot of attention in economics is the Avner Greif's work on Maghribi traders, which had very complex trading relationships, long-distance trade, based on trust without any state-like institution doing that enforcement. Or another example, which is even more telling, is that was very influential in political science, for example, is work by Robert Ellickson, who looked at cattle ranching in Shasta Country, where even though there was a law in the background, people ignored the law, and they had their own social norms for enforcing how cattle should or should not trample onto this or that property. So I'm going to contrast that, or Alex and I contrast that, to centralized enforcement, which is similar to sort of public order, where transgressions are punished by specialized agents tasked with direct punishment, so law enforcement officers. And we're going to see that, miraculously, the equilibrium will be that this can happen and will happen, and in fact, it could be the best thing that could happen, that this could take place without disruption in the cooperative behavior of society. And I'm going to try to make that specific, and that's where things start getting interesting. Okay, so in other words, getting a little bit more into the sort of structure of the question, and then I'll describe the model, and then I'll describe the results, is that we're going to try to ask two questions. Imagine that there are these states agents. Okay. How do we make sure that they behave properly? So we have to give them incentives too. So the problem is not just a simple one that, oh, the state comes in as Deus ex machina and does everything so well, and of course, then we want the state. But of course, anybody who has interacted with any state be it in the the motor vehicles office, tax office, the police officers. You know that it does come in with some iffy behavior too. So we have to sort of live with that. So our agents are going to be not so altruistic unless they are given incentives. So we have to deal with that. The second is, let me go back to this sort of room. Okay. So in this room, we could do community enforcement. How would that work? If we have community enforcement, it will sound a little bit strange, but you'll see, it's just a metaphor, but actually some things actually do work that way. That was sort of Kanduri and Ellison's work. It would be that if anybody here sort of engages in disruptive behavior, so imagine Uwe starts jumping up and down in his seat, then from now on, in the community enforcement, we all engage in disruptive behavior. So you all start jumping up and down in your seats. Imagine that. So that's community enforcement. Public enforcement would be, we have a specialized agent tasked with punishments, Hans Werner, for example. So if Uwe jumps up and down in his seat, Hans Werner goes and hits him on the head with a stick.
And if I do that?
We'll see whether we punish you or reward you. We'll see. But the question that I'm going to ask conceptually before you get to Hans Werner's questions, that was part one. How do we incentivize Hans Werner? Part two is, why don't we do both? Why don't we have Hans Werner hits him on the head with a stick, but also other people stop cooperating and behave disruptively? Wouldn't that be even better? We get 2 bangs for the buck. So that's the question we have to ask. So we're going to consider a society consisting of citizens who choose effort, investment, which create benefits for society or for their partners. And we're going to have specialized enforcers who can undertake costly punishments against these deviators, if they want to, or against anybody. Later on, I'll endogenize who becomes a specialized enforcer and a citizen. But for now, let me take that as given. Okay? So we're going to have a matching structure where, for example, Rick and Klaus match as private citizens, and Monica is a specialized enforcer who is tasked with monitoring them. Okay? So what's the problem here? The problem generically could be, for instance, if Rick and Klaus have an asset, we need to make sure that Monica doesn't steal it. That's one problem. So I'm going to ignore that problem, because there's another problem which is even more important here, and instead of 2 incentive compatibility constraints, we're going to work with 1, which is it's costly for Monica to have that stick and hit somebody on the head. So how do we make sure that she does that? It's a costly thing, so she would not like to do it. So we have to incentivize her to undertake the punishment. So the problem here is not to punish Hans Werner because he has punished Uwe, but is to make sure that he actually wants to punish Uwe if Uwe really needs to be punished. So I had to pick on somebody, Uwe, sorry. So the main result I'm going to show you, which might at first sound surprising, but hopefully by the end of the first part it will be much more intuitive, that under some conditions, and in particular the condition is going to be extremely simple. It's going to be that the monitoring technology is sufficiently effective. The best equilibrium, the best ever thing you can do, is to have state enforcement and no disruption of cooperation in society. So we will have Hans Werner punish Uwe, but nobody else does a peep. And we all just go on in our daily lives as if nothing had happened. What happens if Hans Werner doesn't do that? Then all hell breaks loose. Because Hans Werner is the institution in society. If he doesn't do what he's supposed to do, then trust breaks down, and then we all start jumping up and down because there's nobody to look after the herd, so to speak. So that's, it's quite intuitive, I think, but this is going to emerge as the unique best thing that society can ever do. Okay? Conversely, if this enforcement technology is not very good, then community enforcement is best. If it's intermediate, then some hybrid is best. Okay? Now, I'm going to derive these results for today under a relatively simple assumption, which is that I'm going to assume that this is an anonymous world, so I don't see who does what, but I have a ledger that says somebody cheated. So this is going to be perfect monitoring with anonymity. And then we generalize it in the paper to incomplete information, meaning we don't see who does what, we get incomplete signals of who does what, or we can only get information with who does what if we were in the same match with them, etc. Those get much more complicated, so I'm not going to talk about them today. Suffice it to say that you need to do much more work. The results are not quite as strong, but almost as strong, meaning that the best equilibrium now is true under some additional conditions or additional refinements. But the same spirit. Okay? Are we on the same page here? Okay. All right. Okay, so now the model. So there is random matching with a society that has Kn producers and Ln enforcers. Okay? And each match, there are going to be n matches every period, and each match consists of K producers and L enforcers. Doesn't really matter if you want to have one enforcer and two producers, for example, but you know the generality is at no cost. So, and you can do comparative statics with such things and endogenize the numbers, etc. And within a match, the game has two stages: a cooperation stage, where each producer I chooses a level of cooperation xi, which has cost xi. So I don't like to choose this investment or cooperation level. And it creates a benefit f of xi, where f is an increasing function, and with f of 0. And this is the benefit that you create for all other agents in the match, including the enforcers. So this is your, today's little community. You invest and everybody in the community benefits. Then, within the match, there is a punishment stage. After the x's are chosen, the producer chooses yji, a vector with elements yji, which is yji of enforcer j is punishment directed to individual I. So Hans Werner doesn't hit everybody on the head with a stick, but can target that to a specific person. Okay. But he doesn't like doing that. He's a nice guy. He doesn't get any pleasure from hitting people on it with a stick. So he has a cost yji per stick hit, but it creates a damage gyji. So the punishment is costly for everybody, but it might still be necessary, as we will see. And G, of course, is the effectiveness of the monitoring technology here, because you could reformulate the model with some detection probability. It would be very similar, but here I have detection for sure, but then how costly is this? If G is very, very low, it's like near 0, that means he has to hit very, very, very hard to make a minimal damage on the transgressor, so that's not going to be a very effective enforcement technology. Again, G of 0 is equal to 0. So we have anonymous perfect monitoring. So what happens is that after this happens, we go to the next period. In the next period, you have no idea who did what in the previous period, but you know that there was this vector of cooperation levels and punishment levels in society. So in other words, I know that there has been no transgression or some transgression, etc., and whether it's been punished or not punished, but I don't know whether that was Klaus or Monica or Rick or Susanna or Florian. I have no idea. An alternative would be if I were to choose my production decision before I knew the identity of the matches. Then that would be identical. So that's an alternative assumption if you like that one better. Okay. And then it's a repeated game, and people have a discount factor, and they play this game over and over again, rematch play, rematch play, rematch play. That's it. That's the game. So the equilibrium concept is perfect Bayesian equilibrium when we look at the incomplete information version, but here it's almost complete information because you know stuff, you just don't know identities, so you could look perfect Bayesian equilibrium, or you could look subgame perfect equilibrium. Right now, just let me talk about subgame perfect equilibrium because it's just easier to sort of think about, but it's identical in this anonymous matching game. In the case where I have incomplete information about what happened, then you need to define perfect Bayesian equilibrium a little bit more carefully and work with that. Okay, so I talked about these two extremes. I'm not going to, that's crucial, I'm not going to restrict myself to these two extremes. Anything is allowed, both for the players and for the comparison set, which is I'm going to say, what is the best equilibrium? So what does that mean? I compare that equilibrium to anything else that's also subgame perfect equilibrium. The set of subgame perfect equilibriums is huge here. And this is a technically challenging problem in general. Why? Because in repeated games, both complete and incomplete information, what we know quite well is to do something rather boring, which is to do folk theorems. But what we are interested in is not a folk theorem, because folk theorem says, oh, you can do the best thing ever if the discount rate is sufficiently high or close to 1. But what we are interested in is take the discount rate to be any number, and for that value of the discount rate, compare across equilibria. So that means that you need to have an implicit way of characterizing all equilibria, or the relevant equilibria, for this, which is this entirely big set. So I'm not going to restrict that set. So I'm going to make that big comparison. But still, I'm going to give you some clues by focusing on 2 types of equilibria, because thinking about them is already going to give us A, what's optimal under many conditions, and B, a lot of the intuition. And those 2 are exactly what I described verbally. A contagion equilibrium, so Kanduri equilibrium, and then our equilibrium, which I'm going to call a single punishment equilibrium, for reasons that should be obvious or will be obvious. Okay, so this is the grim trigger contagion strategy, which is that each individual plays essentially this 2-state automaton. Each individual is in either a normal state or an infected state. In a normal state, you do what you're told, what you're supposed to do along the equilibrium path. So everybody cooperates at the rate x hat, whatever that x hat is. We have to find the best x hat within this class, as well as whether this is the best class. Or you could be in an infected state, in which case everybody cheats. Everybody does the worst that they can do, which is 0. And enforcers do nothing. There is no role for specialized enforcers. They just go to sleep. They get the benefits, of course, but that's it. How do you go from normal to infected state? If you ever see any single individual in the public ledger or in your complete information about the past, because as I said, the alternative interpretation is I have complete information, but I choose my effort level investment before I know the identity of my partners. Either way, if you see ever any deviation by anybody in this room of 80 people or whatever, then I deviate and go to the infected state, and from then on I'm in the infected state. So it's a 2-state automaton. There's one state in which I do one thing, there's another state in which I do something else, and there's a very simple transition rule that takes me from one state to the other, and the infected state is absorbing. Once I'm there, I stay there forever. Okay? It's very simple. So you can then choose x hat such that this is a subgame perfect equilibrium. We're going to instead also work with, not instead, but going to be very relevant, a single punishment equilibrium. This one, on the other hand, is also a 2-state automaton, but a different one, and it also involves the enforcers. Now, every agent is again either in a normal state. In a normal state, producers play some equilibrium level x star, calling it differently so that I can distinguish it from the contagion. And each enforcer chooses yji for all I that have played x star. Or if there is an individual who has deviated from x star, they go and punish him at the rate y star. This is all in the normal state. I do this, play x star, punish if anybody has deviated from x star when I'm in the normal state. In the infected state, all players take action 0. Producers don't cooperate, enforcers don't punish. And how do I go from the normal to the infected state, which is again absorbing? I only go there if I see a producer deviate and an enforcer not punish. So in other words, in the contagion, if Uwe jumps up and down, that's enough. We all go to the infected state. Here, if Uwe jumps up and down and Hans Werner does not punish him, then we go to the infected state. But if Hans Werner punishes him appropriately, then we stay in the normal state. We have to continue with our seminar. So, Hans Werner, you know what you have to do. Those are the single punishment strategies. Any questions? Yes, Lucas?
So basically what the punishment equilibrium does is just to add a layer of a punishing agent to prevent this very inefficient collaborative punishment. But it can still happen. So would it be better even to have more layers of punishing agents to prevent happening, to prevent the cooperative punishment to happen?
Sure. So you could add another layer here where we punish the punishers if they don't do what they were supposed to do, in which case that would say that society breaks down. We have an appendix which shows a little bit of that. In which case, if a police officer misbehaves, you again continue cooperation. But if you see a Supreme Court judge take a bribe or act really in a bad way, then cooperation breaks down. Yes, please?
Why is it so important to, once we lose trust and go to this infected state, to stay there all the time? Wouldn't it be enough to just do it?
Let's come to that, okay? So that's a good question, but I can't answer that because so far I'm not telling you anything other than these are some strategies I'm going to consider. Okay. So let me get there in 3 slides. Okay. Yes, Monica.
I mean, so far, equilibrium, nobody should deviate. So the cost of punishing therefore don't matter because it won't happen.
Of course. Of course. But it has to be still incentive compatible because we're looking for a subgame perfect equilibrium. So it's not enough for Hans Werner to say, I'm going to bring all of these tables, all of these books on Uwe, because he will never do that. That's just too costly. So we're looking for a subgame perfect equilibrium. So firstly, let me define within this narrow class of single punishment equilibrium, what's the best one? Obviously, the best one is the one that maintains the highest level of cooperation. As Monica said, the level of punishment doesn't matter along the equilibrium path, so I can define the best one simply by looking at the highest level of X star. But the highest level of X star, as of course you can immediately guess, is sustained by the highest level of Y star, so therefore I need to have a pair X star, Y star that satisfy this. Quite intuitive. Why? This is what I'm supposed to do. What happens if I deviate? Nothing else, but I just get hit on my head with a stick. How many times do I get hit by the stick? In this room by once, because there's only one enforcer, but if there were two, so that's why L enforcers. And how hard do I get hit? G of Y star, where Y star is the other pair in this vector. What is Y star? Well, now Hans Werner has to think about how much cost do I save by not doing the punishment, and what's the cost of future cost I'm incurring by deviating from the equilibrium. So the cost he incurs is Y star. What's the future benefit? Well, the entire future cooperation is deranged by that. The value of that to Hans Werner is k of f of x star in each period in the future, so it's delta 1 minus delta because it starts tomorrow and it's discounted, so delta over 1 minus delta. So if we want Hans Werner to hit him on the head with a stick, he will do that, but if we want him to bring all of these bookshelves, that's too much for him. Okay? So that pair defines the best single punishment equilibrium. Okay? All right. So here is the theorem. And so now I will answer both your question and I think a slightly deeper answer to Monica's question. Let's define this number, M, which is just a combination of n, number of agents in society, k and L. What its form is doesn't really matter, but I just need it. Okay? So if g prime of y is greater than m, meaning that this technology, it's not the level of the technology that matters, it's the derivative of the technology, is greater than m everywhere, then the single enforcer punishment strategy profile with x star, y star is the uniquely most cooperative equilibrium. Meaning that A, there's no other subgame perfect equilibrium that can achieve x star, that can achieve anything other than x star, and B, there isn't even another one that achieves x star. Okay? So that's the main result. So that's the result that says, in this society, at least as I have defined it, and of course it's an artificial society, but it's supposed to be an sort of an approximation to some aspects of how our society works in a stylized manner, the best thing is actually punish Uwe, but let society go on. And I'll try to explain that. And conversely, if this g prime y is very bad, so it's less than some small eta, then the contagion strategy profile attains epsilon of the maximum level of cooperation. You can do a little bit better by using these very complicated enforcements, but it's essentially not worth it. Okay? But of course, there's a big gap here because this eta is not m. So in between, you do something hybrid. And I'll tell you what you do there, but it's not really so important. So the main thing now I want to do is answer your question and Monica's question a little bit more deeply. Why on earth is this the unique best equilibrium? Now, the first thing you should think about, and unless you think that, it's not interesting, that this is a very surprising result. So can somebody answer why is this a surprising result? So that I can explain why it is actually true. Okay, so the reason why it's a surprising result is because we know from general repeated games, for example, Abreu's 1988 paper, that there is one principle in repeated games. If somebody doesn't do what they have to do, punish them as harsh as you can. Okay? So what is the harshest punishment we could do to Uwe if he jumps up and down? We could have Hans Werner hit him on the head, plus we also cease cooperating. That seems like the harshest punishment. So why on earth are we doing that? Are we not doing that hybrid? We ostracize him as well as punish him. Why not go for Abreu's really grim solution? What's the answer?
Too costly.
The answer is not that it's costly, because all of this, as Monica said, is off the equilibrium path. The answer is that we have to worry about Hans Werner.
We have no way of punishing him.
Exactly. So we were incentivizing him by saying, well, you better do what you're supposed to do, because otherwise you're going to lose the trust of the society. But if we send society to zero, that's no. But that still doesn't answer the question. That says, okay, this might be better than that extreme case. But it could be a hybrid, where Hans Werner does the punishment he's supposed to do, and there's a little bit of ostracism or contagion. So we have to consider all of these things. But the reasoning turns out that what we do is when we reduce Uwe's utility by a small amount by not cooperating, in fact by an amount, say, G prime, the cost of that to Hans Werner is exactly from here is delta 1 minus delta k. Because if we do a little bit of reduction, that also means Hans Werner's future cooperation value is lower. So we have to reduce y star a little bit. So then we have to compare these two, and miraculously this condition is exactly what you need. So that's the intuition. So that's the result. But specialized enforcement is not more likely to emerge in a society that's purely more productive. Or the delta discount factor. Those are irrelevant. The discount factor is not here. Because those are already, in there is a discount factor here. Oh, where is it? There's a discount factor here, and there's a discount factor in the contagion, and they come in the same way. But what's relevant is just this G function. So as long as we have a good monitoring technology, then we can trust the state. Because we endogenously form social norms, just like what I was talking about the Athenians yesterday, that make sure that the state behaves. So I don't know whether is that the ordoliberal idea? Perhaps. So that's the result. Now I can give you more intuition, technical intuition, etc., but I was essentially given it, and this is like the technical intuition. You go by line. This is not the proof. The proof has to be, now you have to consider the entire set of things, and it's a little more complicated, but let me not get into the details. Instead, let me just give you, let me not say the uniqueness either, it's just already involved. What happens if we are in the interior region? Things are more complicated, so, and one of the complications is that punishments are a bit like money burning. He can punish, and essentially it's costly for him. So to make it more reasonable, you also want to allow some other ways of money burning. Whether you do or not doesn't affect what I've told you so far, but once you allow money burning, then actually you can have a tighter characterization of the middle. then the single enforcer punishment strategies are not optimal, and the most cooperative involves some amount of community enforcement. So that's what you can show. And then the final thing you can show is that now if you allow society to also optimize over the number of specialized enforcers, then actually it's much easier to get community enforcement. So in this case, just one second, and in this case, it seemed like community enforcement was a very pathological case because we require G prime Y to be very, very small. That's because we have these enforcers lying around, and you might as well use them. But now we're saying, well, actually, you can turn them back into producers if they're that useless, and then you get community enforcement under more reasonable conditions. Yes, Monica?
So, but your result then implies that you want to pick somebody as a state enforcer who has little cost, low cost of enforcing.
That's right.
So you really want somebody who is...
Who loves, he's sadistic, yes.
Yeah.
That
doesn't sound true, no.
Oh, no, my God. Have you ever interacted with immigration agents?
I was more thinking of the mafia now, and it's
Right.
really not the ones you want to run the country.
Well, I mean, I think it depends on what aspects of it that, you know, I think certainly you don't want them to punish when they're not supposed to punish. But you want them to punish when, so if, for example, there are the types that, you know, Klaus sometimes talks in his papers with FAIR, I guess, you know, these punishers who punish if you deviate from norms, those are the guys you want, for instance. But we don't do any of that because that's how we started. We also had heterogeneous types here. With heterogeneous types, optimality becomes much, much harder to establish. So this is already an 80-page paper, too long. So like a 35-page appendix, so you don't want to go there. But, you know, yes, your intuition is exactly right in that case. Yes, Klaus?
So one other question. So one important assumption here is that the community enforcement, if this breaks down, it breaks down for everybody,
Right.
including the enforcer.
Yes.
So if you could distinguish enforcers and other
Beautiful
people,
question.
then
So
you
that's
could
why,
only...
that's why
Yeah?
is this paper 80 pages? Because we have to do 3 other things, or 2 other things. We have to do these things and prove them, but then we have to do all the incomplete information stuff, but then we also deal with ostracism. So right now there's no ostracism allowed. So then what we do is we allow ostracism, which means that you can actually have cooperation cease specifically for Uwe, but not for Hans Werner Sinn. And what we show is that it's exactly the same result. So with ostracism ceased, with ostracism, the best thing is 1 period of ostracism towards Uwe, 1 period of punishment, and then you go back to the normal. And the logic is essentially you don't want too much ostracism either, because that's going to then make it lower value for other people, because whoever now becomes Uwe's partner in the future would not want to cooperate because they were just indifferent between cooperating and not. So we have to reduce their cooperation levels. So the same logic now works with ostracism. So very good question, or so we think. Okay, that's it. That's the first part. We're done. I mean, you can do comparative statics and more stuff, but they're all obvious because I've given you the equations. And the most interesting one is this G stuff. So I think the most interesting here is a conceptual way of thinking of why, A, it's better to have the state do that rather than the clan families of the Somalia. But once you have the state doing, you don't want them interfering. You don't want, you know, vigilante justice going on at the same time as the state. So, under some conditions, and under others you might. Okay. So part 2. Any other questions? Yes, please. So.
Who determines the enforcer?
So here all the agents are homogeneous, so that's per Monica's question, so it doesn't matter who's the enforcer. So in some sense I said unique, but what I should have said essentially unique, because if I could choose the identities of enforcers, there's a, you know, I could choose anybody. But if you had heterogeneity, then there would be an interesting choice.
But do the enforcers have the same utility from life as the producers?
They do. They do. They are exactly identical. Okay, so the second part. So the second part is quite different, but as you'll see, very related again to the issues we talked about yesterday. And in fact, it's very related to public finance. Because, I mean, this was implicit yesterday, but let me make it a little bit more sort explicit, perhaps repeating myself, but sometimes it's useful to repeat oneself. So in public finance, which is a venerable part of our profession, we take the state as given. Not only we take their capacity as given. We assume the state can tax, can regulate. We ask questions, okay, if you put this tax, what's the burden? Who should it get? We ask even more sophisticated questions, dynamic optimal taxation. But then you look at around it, it's half of the world lives essentially with almost no state capacity. No public goods, very little roads, no sanitation, no indoor plumbing in some parts, no sewage system or access to water. And much of that is because the state is not even there. So essentially the things that we take for granted from the local state, especially in a country like, perhaps France is an exception, I don't know. But most countries are pretty decentralized when it comes to local service delivery. Germany certainly is, the US is, Canada is, Brazil, India. There's all these local workers, local post offices, notaries, health clinics, local police officers. They do the policing, health services, all the certification, bureaucratic functions. But many parts of the world, those would not be present. So if you don't have them, you can't do public finance. So the first step is, how did they actually emerge? And once you answer, or you can have a strategy for answering, then you can ask, what's their impact? Once I have these state presence, does it really help public good provision or poverty reduction? Now, this is what we started investigating. And then it suddenly became sort of quite clear to us that you can't just investigate this question in itself. Because, again, the context that we were doing this was in Colombia, but I think the sort of the general question could be posed in other places too, is that if you have a municipality, a neighborhood of, let's say, 100,000 people, or that's a bit too big, so 25,000 people, it's got its own boundaries, but it's totally lawless. It has no police officers, no bureaucrats, no notaries, no post offices, no health clinics. That won't just affect that place, but it will affect its neighboring places. Diseases can't be controlled, criminals can go from one to the other, there is total chaos. So you have to sort of think about not just the direct effects of local state capacity, but you have to worry about how it interacts with national state capacity and how it might have negative effects on local neighborhoods. So this is sort of the beginning of the project with Camilo Garcia Jimeno and James Robinson. So we have to think of these spillovers, but I'm going to show you, once you start thinking of spillovers, you also have to think of strategic interactions. If Klaus creates externalities one way or another on Rick, is he going to overinvest, underinvest, free ride, complements, substitutes? So we have to think about these things. And we have to think about them conceptually. That's not that hard. We understand games of this sort. But we also have to try to empirically identify them, which is quite a challenging task, but a fun task, as I will try to explain. So there will be some methodology here. Okay? So in other words, in this paper, what we try to do is we set up a game theoretic model, not for its own sake. Now, I'm not going to tell you the interesting properties of the model, because the model is as simple as it can be, and it's quite standard in some way. But this game is then going to, which is a game between the municipalities and with the national state against the municipalities, is going to be used to estimate, using data from Colombia, 3 different things, actually 4 different things, but I'm not going to talk about the 4th one. That's why it doesn't have a bold today. Well, I have slides, but I'm not going to get to it. So it's as good as I don't have it on the slides. If there is great demand, I can talk about it tomorrow at the beginning of the other lecture. But we're going to estimate the own effect. How much does Monica's state capacity or state presence matter for her own public good provision and poverty and other outcomes? How much does Monica affect the rest of the neighborhood, her neighbors? We'll have to define who the neighbors are, of course. And the interaction effect. Meaning, is Monica a complement or a substitute free ride or not with Ludger or Rick, and also the relationship between local state and national state. I'll define all of that. I won't ignore 4 for in the setup of the model, but in the estimation, I'm going to abstract from it first, and then I'll tell you that everything is the same if you take that into account. Okay, so is the conceptual question clear? Okay. Now, lots of challenges here. First of all, at the best of times, this is a structural estimation because you have a game and you have to estimate. But in addition, there are the usual and somewhat less usual econometric problems. State capacity choices are endogenous, so you have to deal with that. A place that has lots of police officers might be very different from the one that doesn't. The estimation of spillovers is plagued by 2 sorts of things. One is called, following Mansky, contextual effects. Contextual effects refer to the following, which is that I'm trying to estimate at the same time what Hans Werner's impact is on himself and what is Hans Werner's impact on Florian. Okay? But that's a difficult problem because if Hans Werner's choice is endogenous to himself and Florian's choice is endogenous to himself, but they have similar characteristics, which they might because they are geographically adjacent to it, they have been subject to similar historical processes, they're going to be correlated. So with that correlation, things that are not due to the causal effect of Hans Werner might actually load on to Hans Werner's contextual effect. So that's the difficulty of estimating the contextual effect. The third one is even a harder problem, which is called endogenous effects. Now, at first, it would appear that our model shouldn't, at least the way that I've described it, shouldn't have endogenous effects. But we'll see that it implicitly does. What are endogenous effects? So in the contextual effects, I asked the question, what is the impact of Hans Werner's characteristics on Florian's outcomes? Endogenous effects would be the question, what are the impacts of Hans Werner's outcomes on Florian's outcomes? And that's considerably harder than the contextual effects because now correlated effects are just going to create a total havoc. Now we'll see why whenever you have a interesting model of contextual effects as a game, that will lead to endogenous effects, which should not be a surprise to anybody who's played with Nash equilibrium before. But I think it's sort of was never noted in the empirical literature. So in the empirical literature, there's a big distinction between estimating contextual effects and endogenous effects, but actually it turns out that the two are embedded in each other. Okay. So how do we do this? Well, after you develop the theory, which we do, and some of the simple econometric theory, it all comes down to instruments. But now instruments used in a structural fashion with the structure of the game. But of course, you need to also have plausible instruments. I'm not sure whether we have the best ever instruments in the world, but we have some interesting sources of variation because there are aspects of Colombian history that are quite idiosyncratic across municipalities that determined where the colonial state was located about 150 years ago, or 100 years ago. 150 years ago, essentially.
The trade routes?
Yes, not trade routes, actually, royal roads. Okay. And it ceases to be relevant after that because essentially they were totally thrown away, and I'll explain all of that. So that's the historical instruments that we're going to use. Okay. And then one nice thing that we'll do, and this is what I will definitely get to, or I will try to get to, is that one payoff of doing all of this work is that you answer the questions that you started with, but you can do counterfactual analysis. Counterfactual analysis is pretty boring in a model that doesn't have a structural aspect in this game theoretic thing because the partial effects, the derivatives which you're estimating give you what you want. But with a game theoretic structure, counterfactual effects are more interesting, and we'll see that they turn out to be quite different. Okay. Let me give a very quick preview of results, and then let me actually give you a 3-line preview of results. First of all, A, we argue and we show hopefully that this can be done. B, that state capacity matters quite a bit. It matters, your own state capacity matters a lot. Neighbor state capacity matters a little bit. But in equilibrium, that little bit gets hugely amplified. So those are the results. And then I'll try to put flesh on those bones. But before I do that, let me say a few words about the Colombian context to justify both why this is an interesting setting and that this is in fact a problem. You know, in Germany, perhaps this would not be a very interesting problem because local state capacity is fairly well developed right now. In Colombia, it isn't. And even today, I'll show you the descriptive statistics come a little bit later. But amazing lack of public goods are just striking across Colombian municipalities. But also throughout the history, the state was most notable in most of the country by its absence. So for example, in 1912, the journalist, social scientist said, in most municipalities there was no city council, no mayor, no district judge, no tax collector, even less for road building boards, whom to count for the collection or distribution of rents, who may be data collect property taxes or any other contributions. So total absence of state presence in most municipalities. And that sort of changed a little bit over time. And there was a period in which there was centralization of some services, didn't work very well. But the period we're looking at after 1993, there was a huge decentralization. But it was decentralization in the context of very, very unequal presence of the state and very unequal budgets and so on. So, but let's now go to the model, and then we'll come back to the data and the context a little bit more and on the historical variables then. So we're going to have a network game of public good provision. Why a network? Well, because it looks like a network. Monica is neighbors with me and Hans Werner, but Hans Werner is not neighbors with, Uwe, etc., etc. So not everybody is connected to everybody else. So it's not a pure externality game where I create an externality on everybody. Okay? So each municipality is a node. Each adjacency implies a link. And the strength of the links is going to depend on geographic conditions, distance, altitude, elevation, etc. And then we're going to have utility functions, which are going to be reduced form. So I'm not going to model the politicians and principal agent problems. And then there's going to be a national state as well as the local state. The national state's going to have heterogeneous preferences over outcomes. So it's this 2-layer game, essentially. So let's do the network structure first. I denote the adjacency matrix, which determines a matrix representation of this network by n of delta. Delta is a parameter to be estimated, but n is simple otherwise. It's 0 if you and I are not neighbors. We do robustness by considering 2-degree neighbors or other functional forms, doesn't really matter. And if you and I are neighbors, then the strength of the link between us is Fij, where f is a function of distance and the variability in altitude. And then there's a parameter delta which says how much this matters, how much this matters. Why the variability of distance? There's a summary of how difficult it is to traverse the distance. But especially in Colombia, the geography is very complex. There are these big mountains that separate places, and some places might be close to each other, but very, very difficult to get from one to the other because the mountain separates them. So you have to take care of that. Any questions so far? Yes, Monica?
So if you're at the same altitude,
Sorry.
So if you're at the same altitude but a huge mountain in between, how is that accounted
So
for?
that's because it's not the altitude, it's the variability in altitude. So we do the variability
Along the path.
Yes, along the path, along the best path. Okay. So here is the outcome equation, which means this is the equation at the end that I'm going to try to estimate the parameters thereof. So Pij, you can think of Pi if you want. J is not so important. So J is allowing the fact that we can have multiple dimensions. And in the structural estimation, you can pool all of them. But for right now, just think of it as Pi. Pi is the long-run outcome of choice of municipality I. And it depends on SI, which is the state capacity of municipality I, and a bunch of interaction and spillover terms. Si is multiplied by kappa I and xi. Okay? So y, two terms and yi's as subscript. Well, hopefully it will become clear, but what this means is that there is a main effect which is going to be parameterized as functions of covariates. That's kappa I. So that's where covariates are going to come into this equation. So think of kappa I as functions of some x's. Okay? Plus there is this xi, which is an error term. Why on earth do you have an error term here? Well, we'll see. Then psi 2 times ni delta s. What's that? S is the column vector of all other, column vector of all municipalities' state capacity. So it lists them. Uwe so much, Klaus so much, Lucas so much, etc., etc. Ni delta is the row vector of the adjacency matrix for municipality I. Remember, it has a 0 for yourself, so yourself don't appear in that. So then when I take the Ni delta S, that's the inner product. So essentially what I'm doing is I am weighting every other municipality with their adjacency to me. If you're not my neighbor, I don't care about you. If you're my neighbor, then it depends on all of these calculations that Monica and I were talking about. And then what's this? This is just like that, but it also multiplies by SI. So that's the interaction term. So this is a spillover effect. This is an interaction term. This applies to me regardless of what my level of state capacity is. This is an interaction. So, I might benefit more from your police if I don't have a police myself, or if I have a police myself. So that's going to depend on psi 1. Okay, so we want to estimate the mean of kappa I, so the local average treatment of kappa I, and then psi 1 and psi 2. Greek letters get very confusing. Klaus? SI itself is an aggregate of local state capacity investments and national state capacity investments with a CES form, although today, for most of the talk, I'm going to talk about alpha equals to 1 case where I ignore the national state. So it's a little bit simpler, and it turns out that the results are, except for one wrinkle, almost identical. So if you want to focus on that case, you may. Any questions? Okay, and then final element, utility functions for municipalities. They maximize outcomes. If there are j outcomes, the average of the outcomes, minus cost of investment, which I've taken it quadratic so that this becomes a linear quadratic game over a network. Why do I like that? Because it has an explicit form solution. So you can, maybe it becomes easier. Actually, it doesn't really have an explicit form solution when alpha is not equal to 1 and everything works, so the linearity is not important. I mean, the explicit form solution is not important, but in the case where alpha equals to 1 and I ignore the national state, then it becomes a linear system, and then it's really easy to, which is the case I'm going to talk about, so it's really neat. And then there is a national state which maximizes this thing where the national state's a bunch of zeta i's, which are known to all of the agents in this economy. So this is a complete information game, but are known to the econometrician. So if you do the national state, that's why it's a hard problem, you have to estimate these xi i's also. Okay. All right. All right. So this equilibrium, this game has an equilibrium that can be easily characterized in terms of first order conditions in the Kuhn-Tucker form. And they take this form, which is that the cost of investment to me has to be counterbalanced with the benefit. The benefit is I get a direct benefit, plus I get a benefit from the interactions. And then if that's too low, I go 0. If it's equal to, or if I do a positive level, if that's equal to 0. At this level of generality, one important result is that this thing is positive, meaning this cross partial is positive, and this is a game of strategic complements if and only if psi 1 is positive and vice versa. So always this psi 1 is the parameter that will tell you whether we have complementarity or free riding. Any questions? So let me now simplify just a little bit, or quite a bit, I don't know. And I promise I'll tell you in 30 seconds what happens when I don't do that. But for now, alpha equals to 1, so that it becomes an exactly linear quadratic game. Then in that case, the best responses are linear, and under somewhat weak conditions, I don't know, under some conditions, we can also just focus on interior equilibrium. If you don't interior, that's fine, but interior equilibrium is so much neater. Let me show you that. And the interior equilibrium looks like this. And these are, of course, nothing but the best response functions in a linear quadratic game. SI is equal to my direct benefit, kappa I over theta, discounted by the marginal cost, and the indirect effect, zeta I theta over S. Now you see two things from this equation. First, why I needed the zeta, so this term here. If you don't have this term, which means that the marginal return to each state is a known function, then the best response equation doesn't have any error term. So in any game, if you want the best response function to have an error term, do you need that the marginal returns have a random component? So that's, I think, is pretty reasonable. The second thing is that, let's look at this equation. This does not have any endogenous effects. Remember, the endogenous effects are Hans Werner's outcomes influence Susanna. But this does not have any. It has interaction terms, spillovers, own effects, but no endogenous terms. But of course, what is the Nash equilibrium? Nash equilibrium is a bunch of best response equations. My strategy depends on Monica. Monica's strategy depends on Klaus. Klaus' strategy depends on Uwe, etc., etc. What is that? That's an endogenous effect. So we have the endogenous effects back through the Nash equilibrium. So in other words, whenever you're going to deal with a Nash equilibrium, unless it's a trivial Nash equilibrium where everybody has a best risk dominant strategy, everybody has a dominant strategy, then you have to the endogenous effects. So you can't escape them. They're tougher to deal with, but this distinction that endogenous effects are not there, so therefore my job is easier, is not non sequitur. It's a running argument I have with my colleague Josh Angrist. That's why it's emphasized. Moreover, this is a very simple game, so you can find easy conditions. For example, some sufficient conditions. There are other sufficient conditions appear in work by Jan Bramule, Rachel Cranton in 2012 AER paper. If the minimum eigenvalue of this matrix is less than this game has a unique Nash equilibrium. Also, it has a unique Nash equilibrium under strategic complements, etc. So, moreover, if this condition or some cousins of it are satisfied, this equilibrium I'm characterizing is the solution, or this equilibrium, that's the joint solution of these best response equations, is the unique long-run rest point of any number of adjustment processes. So for example, if municipalities are playing backward-looking best responses, those best responses uniquely converge to this equilibrium. So in other words, because we're looking at the long-run outcome, we don't need to make very sophisticated assumptions about these municipalities' game theory playing skills. They could just be crawling towards there. Okay. All right. We're almost there. So now comes the next step, next tough step, which is, now let's take this guy, which is a relationship that has to hold in every equilibrium, and stick it back into here. Because this equilibrium cannot be holding independently from that equilibrium. Equilibrium says they both have to hold at the same time. But when you do that, what happens is that the outcome equation simplifies and becomes this thing. This is a quadratic equation, but perhaps distressingly, two of our favorite parameters have disappeared. Kappa I has disappeared and psi 1 has disappeared. Kappa I is the own effect. Psi 1 is the interaction effect. Psi 2 remains, but actually you can show with some simple econometrics that you can't even estimate psi 2 consistently from this equation. What's going on here is that, of course, we're looking at a Nash equilibrium. In Nash equilibrium, there isn't independent variation in Clauss's strategy and the outcome, because Clauss's strategy responds exactly to the marginal returns. So the two are linked, and you can't estimate them independently. So if you're just left with this equation, you can't estimate anything. But fortunately, you have this equation and this one. So you could estimate the two simultaneously, and then you can recover all of the parameters. So in particular, if you estimate this equation, you can consistently estimate theta and psi 2. And then once you have theta, you can estimate psi 1 and kappa I. And you can get the local average treatment effects as the constant of this equation. So all of the parameters are actually estimated, are identified. Okay. All right. So then how do you do that? You could do it in whatever way is your favorite. You could do IV. You could do system GMM, because there are many equations. You can estimate them simultaneously. You could do maximum likelihood, et cetera, et cetera. That doesn't so much matter. But of course, you have to grapple with endogeneity issues, which is our next topic. So before I do that, let me give you, so that you don't get bored with conceptual stuff, let me just give you one sliver of data, and then we get back to business. Okay? So we're going to use this cross-sectional data. It's quite rich. We have a lot of things. We have the adjacency matrices, all the distances. We have data on almost all of the Colombian municipalities. Some very isolated ones are left out. And then lots of outcomes. So we have lots of covariates, soil quality, about 50 variables for soil quality, temperature, geographic variables. We have a bunch of historical variables I'm going to come to. But also in terms of outcomes, we're going to look at, we have some other outcomes. We're going to look at falsification. But the main outcomes we're going to look at are a life quality index, which is essentially sewage, water, garbage collection. So basic things that everybody should have. How can you have number of people that don't have sewage, water? Well, you'll see. Average coverage rate of public utilities. This is just aqueduct and sewage and electricity. Fraction of the population above the poverty line. This is a very low poverty line. It's not like in Germany or the US. And secondary enrollment rate. So these are Colombian municipalities. Let me, since time is short and outcomes are many, let me just, for the rest of this talk, just draw your attention mostly to the poverty rate, because it's easy to interpret. So this is the histogram. So about 50% of municipalities have, in Colombia, have poverty rate greater than 50%. Or actually 60% of municipalities have poverty rate greater than 50%. So it's not just municipalities that you have 10% poverty rate like you have in some US neighborhoods. Almost everybody, is in poverty. So there are somewhere 100% is above the poverty rate line. So for local state capacity, we have number of municipality level public employees, number of municipality level public agencies, how many things they perform, and then we have national number of national bureaucrats, etc. And then we have historical data from historical sources on number of crown employees, count of the number of state agencies, all around early 1800s. And then we have lots of historical population, other data from the 1843 census. And then we have these royal roads, which are the ones that were being anticipated. So royal roads are really cute. So you could make arguments about, these crown employees. Perhaps they, but I'll tell you a little bit about the history of where they went, etc. So this is also attractive. But the royal roads are really attractive because essentially what the Spaniards did when they took over, that Colombia, most part of Colombia was under the Inca Empire's dominion. So it wasn't really part of the Inca Empire as like a core, but it was under the control of the Inca Empire. And the Inca had set up roads already. So the first thing that they did is they took those roads and expanded them a little bit in order to be able to use to pass their troops and etc. So very, very basic stuff. But the Inca, of course, they had a very different organization and they were interested in very different parts. Their roads were crazily non-convenient. They went around mountainous areas, winding down, you know, way before modern transport. So let me actually show you. Oh, okay. So these are royal roads. This is one royal road. So the royal roads were things like this. So when later on in the late 19th and early 20th century, Colombia started building its own public road structure, and then later on the highway structure, they entirely threw away the royal roads. They did not build on the royal roads. So that's why the royal roads are a sort of an attractive source of variation, and then we do everything both with or without controlling for the current road network, and it has zero impact because it's entirely orthogonal to royal roads. And the crown employees, etc., those are also interesting because the crown employees were put very much only in places that were of strategic military importance, which of course none of them have any importance, or they were gold mines, which again the gold mines stopped functioning about 100 years ago. So, and if anything, you would worry about these gold mine areas because they had slavery being poorer, etc. So, but I'll show you results, or I'll tell you results about 1, 2, 3 ore instruments, etc. So they're very similar in terms of results. So, okay, we're almost where we're at what we do, and then I'll tell you what we do, and then I'll show you what we do, and then we'll be done. Okay? But before I do that, I'll tell you what we don't do, because I think it's fun and it's sort of instructive. Because although we don't do this, it's actually, for those of you who might be interested in these issues, it's something one could reasonably have done, and I'll tell you why we don't do it. So, because these problems of identifying contextual and network effects and endogenous effects are very well recognized, people have been thinking about them. And you know, Mansky's article at some level is a very pessimistic article because it looks at an externality case and says, you can't do anything, you're host. But then, you know, it was immediately clear to a lot of people that, well, that's not true if there's a network structure, because there's a more complex interaction, perhaps you can exploit it. And the best paper that has that idea is a Journal of Econometrics paper by Jan Bramoulet and co-authors, which has the following idea. Let me give the idea in the context of smoking. So they want to ask, imagine you want to, I mean, you could do it in this context, but I think the smoking is sort of easier to and more intuitive. So imagine that I want to find out whether Klaus smoking has a causal effect on his friend Monica smoking. So that's the question I want to answer. Now, that's a very tough question, as I've sort of indicated, but let me give you more sort of details. The problem is that these two might have become friends because they both like smoking, or they like a lot of things that are complements to smoking. Possible. So that in that case, their smoking will be correlated, but not a causal effect. Or they may both smoke, not because they have become friends for that reason, but because as friends they have been exposed to similar circumstances. Perhaps as friends, they both happen to live near a coal mine, and that has trained them for smoking. So there could be both correlated effects and selection problems that make this a really tough issue. And those are the essence of the issues that I'm sort of trying to grapple with. So here's the Bramoulet et al. Idea. It says that let's find somebody, let's say Susanna, who is friends with Klaus, but not with Monica. And suppose that correlation stops at friendship, meaning that whatever I'm worried about this correlation, it's not correlated between Monica and Susanna because they're not friends. But it's correlated between Susanna and Klaus. That doesn't matter because if there is indeed a causal effect, then I can use Susanna's characteristics that predict smoking as an instrument for Klaus, and then instrument Klaus's impact on Monica. And that's consistent. That's a great idea. So one could use that in any network setting. There's only one problem. What's that? Well, that's one thing, but that's always the case, you know. The network can be mismeasured. You're right. In this case, mismeasurement could be quite substantial. That's an important point. But with a network map, I know that pretty well. So, but it's an important point. But there's another problem. Correlation need not stop at friendship. If Susanna is, you know, neighbors or friends with Klaus, you know, she's not that far from Monica. So perhaps they are actually correlated, and that correlation would make the instrument invalid, and then that could all mess everything up. So that's the one thing you have to worry. And unless you really know something very specific about the structure of correlation, generally not easy, but you sometimes you have a priori knowledge or reasons to suspect you could do it, but we don't do it that way because we're not confident on that. Instead, our idea is very simple. The idea is that if these instruments, whatever they are, like royal roads, are really orthogonal to everything, then when you take their multiplication with the network matrix, that's still orthogonal. So therefore, from one valid instrument, if it's really orthogonal, not just, you know, just happens to be uncorrelated, but it's really orthogonal, I can generate many instruments by taking the same matrix operations as you do for filtering the externalities. So that's the idea. So you can have all of these covariances that are, you know, generally messed up between error terms, but as long as the covariances of the instrument with zeta I is 0, then the covariance, when I multiply it with some known function, is still 0. So that's what we use. So it's a very simple idea. Okay. All right. Now, you might still worry, well, aren't these instruments very correlated? Well, it just turns out they're not. They're not for an interesting reason, and I've already indicated. So, but let me show you first. So these are distance to royal roads correlated with the average distance of royal roads of neighbors. It's positive, but it's not huge. Any geographic variable of this sort is going to have some positive, but it's not huge. That's important. And if you go neighbors of neighbors, which we do also, we use neighbors of neighbors instruments in some specifications, it's essentially 0. What about prosperity light related variables? You would worry about things, you know, perhaps colonial officials all went to the rich places and the rich places are next to each other. No, because colonial officials and state agencies went to these strategic places, and once you were a strategic place, because the Spanish crown was trying to save resources, places around you were not strategic anymore. So that's why that's actually slightly negative. Essentially 0, but slightly negative. So if you're worried about positive, these two should give very different results, and they don't, and that's a nice check. Okay, now back to business. What we're doing is we're going to first parameterize this kappa I as a known function of stuff, covariates, department fixed effects, blah, blah, and some instruments, and then estimate this first stage equation, or you know, it's not best response equation, not first stage, and the outcome equation. You can do that either equation by equation, get consistent estimates and estimate, you know, calculate delta method standard errors, whatever you want to do, or you can do simultaneous equation estimation or systems GMM, all of them together so that you get more estimate or more power, etc. And one other thing, this G function, I'm going to assume is unknown. And also this delta parameter you might want to estimate also. How strong, how much do you care about distance versus altitude, etc. So all of these you could do, and I'll show you how to do that. But since time is running short and I want to leave question both about today's presentation and time for questions for both about today's presentation and perhaps if people want to about the presentation yesterday, let me not go through this in great detail in the parts that I don't need to go through in great details. If you estimate this best response equation, the first stage for estimating it is very, very strong. So the F statistic for excluded instruments is always very high, sometimes super high, or when you do over-identification tests, always satisfied. So at least some obvious but not very demanding things are satisfied. But more importantly, the second stage is quite meaningful. So if you do OLS, which is not what you should do, but it's always a useful benchmark, you estimate the derivative, the local effect, of my neighbor's state capacity on me is this number, 0.016. If you do ID, it's always around there, very precisely estimated. This is controlling for population. This is instrumenting for population, so that you define a population as endogenous, and then you use historical population as instruments for that. Same thing. So there's quite a lot of stability here, and you can never break the stability. But more interestingly, now you can put everything together, and this is still linear IV. So I'm not doing anything fancy with systems GMM. It turns really make much difference. I'll show you in 1 second. If you estimate these things, the second stage, now the IV versus OLS makes a lot of difference, which is where you should have really worried about endogeneity, and you would have been right to worry. So now OLS is 2 to 3 times as large. This is for life quality index, public utilities. It's actually the least is for above poverty line. There it's about 5.2 relative to 3.2. So this is my own effect. How much my own SI affects prosperity. Previously I was looking at how much my SI affects your SI. That's the endogenous effect. Now we're looking at the structurally relevant relationships, which is how much your state capacity affects my outcomes. So it's about 0.32 for my own effect, and this is the externality spillover term. Now, one good thing to start with is that this is between 10 to 15 times larger. So you have a much smaller effect on your neighbors than yourself. So that's a reality check. You should never have, sometimes you see some numbers where, your wage depends more on other people's education than your own education. The education experts are there. They can disagree with me. I don't know. But I think that's already a telltale sign that there's something wrong. Okay? So here this looks good. But of course, this is not the full spillover, because I create the spillover on many neighbors. And so you have to take that into account, etc. And then there is the equilibrium effects, which we have to take into account. So let me actually show you one other thing before I come to the bottom line. Everything is pretty well captured by the linear model. So if you do the GMM, I was assuming this function was linear, and this is how it's estimated in GMM. It's not linear here, but there are so few observations here, who cares? Over the range where the observations are, it's very well approximated by a linear equation. So everything, GMM gives very similar results, and efficiency increases, standard errors fall, things become more precise, but for all practical purposes, we're where we were. In fact, so much so that now I forget whether these numbers are from the IV or the GMM. I think they might be from GMM. I'm not sure. So here is the thought experiment I'm going to consider. This is essentially the bottom line, and then I'll tell you in 5 minutes that it's robust to lots of things, and there are a couple of falsification exercises that are interesting. But so here is the bottom line. Now that we have the estimates, now we can do counterfactual analysis. And I'm going to do 2 counterfactual analyses. I pick what I do, so there's some degree of arbitrariness, but you could pick whatever you want and run them through the model. So the one I'm going to do is I'm going to take all municipalities in Colombia that are below the median of Colombia, which turns out to be much worse than Detroit. It's like really, really bad. I mean, you would not see anything close to the median anywhere in the Western world. I'm going to say, let's take these places that are just so bad that they don't have sewage, they don't have any public officials, they don't have health clinics, they don't have notary offices, etc., tax collectors, and just bring them to the median. And then I'm going to ask, what's the partial equilibrium effect, and what's the equilibrium effect? I'm tempted to use the word general equilibrium, but I think it's not the right word. But I don't know, partial equilibrium and equilibrium, they may not. Partial equilibrium effect is I just make this change, and I hold everything else constant. So in particular, everybody who is above the median gets held constant. Remember, there are a lot of people around the median here too. The above the median ones are not like Munich either. And then I do the equilibrium one, where I say, well, this is a game. If I shock Klaus, that's going to have an effect, potentially could have an effect on other people. And we know it's going to have an effect on other people because we've estimated that. In fact, we estimated that this number is positive and precisely estimated, so it's a game of strategic complements. Meaning that if the other municipalities around you are going to the dogs, you don't invest because you're just losing proposition here. So this is what happens. Let me just focus on this. It's a big change, so it's not a small change I'm considering, but the effect is also big. So the fraction of the Colombian population that's above the poverty line in 2000, or 2001, sorry, is 57%. If we do this change, which is not a modest change, but it's a pretty big change. We're bringing half of the municipalities to something from pretty dismal to halfway decent. That reduces poverty from 43% to 40%. And I can also ask how much of this is because of a direct effect and how much of this is because of the spillovers. And the answer is about 60%, 57% is to the own effect, and 43% is due to spillovers. So that's the baseline answer. What happens if we then take the equilibrium effects? What happens in the equilibrium effects is that essentially what we're doing is we have a bunch of people in this model. Everybody's in their first order conditions, so nobody's at a corner. We're taking in their estimates. So by the way, one thing I forgot to say, after given the estimates, then we check those uniqueness and stability conditions, and they're all very comfortably satisfied. And then the equilibrium is in fact interior as we assumed in the estimation, etc. So then we take these change, we force those guys to their somewhere that's not an equilibrium, and then we let other people now adjust because now the conditions have changed. And then we go back to these people themselves and say, now that people around you have adjusted, I had forced you to go higher. Do you want to go even higher? And some of them actually do want to go even higher, etc. So that whole adjustment takes place because everything's strategic complements. And then we come to a new equilibrium. So the first exercise is a non-equilibrium situation. The second exercise is a change in the parameters of the half of the character places that I have forced them to invest up to a certain level, but then equilibrium. What happens now is that from 57, not above the poverty line, which means from 43% poverty, you go down to 32% poverty. So it's actually a huge effect. And 75% of that comes from the network effects, because all of these investments are being amplified because people are reacting to it. Okay. So that's it. No, I'm not finished, but it's for the rest of you. Thank you.
So I'm just wondering how you can... So if you would like to explain development measured by, manifold measures in a municipality I, you would also guess that development in municipality I is influenced by development in the neighboring municipalities. Yeah. And the question would be how you can, in an econometric model, deal with the spatial lag, spatial structure, and the IV you present.
So we do that. So we do that in one of the extensions. So we can allow one more layer of endogenous effects and then estimate it. It becomes more complicated, but qualitatively things remain similar. So there are more endogenous effects that could be allowed here. But I'm not going to talk about that right now because that becomes quite a bit more involved.
So does this have any direct implication for what the central government of Colombia would do, should do, could do?
Okay, I was not going to talk about that, but now you forced me to. Yeah. Okay, so but that's a couple of slides later. So let me just tell you 5 things extremely quickly, just to show you that this actually turns out to be very robust. So, as I said, the systems GMMs works. Now, you can control for networks characteristics, network centrality. That doesn't really matter above and beyond what we've looked at. We do a placebo exercise where we look at outcomes not determined by local state presence. In particular, there is primary schooling is actually compulsory in Colombia. It's one thing that the Colombian state does seem to do okay. And immunizations are also centralized, so they're not affected by local state presence. Shouldn't be. And we do as the other outcomes, as I showed you, are very strongly predicted. We do everything else with these. We repeat this exercise with these two variables, and they don't matter. Now, one other thing that you might worry about is that perhaps what we are capturing is an entirely different effect. That our instruments are, of course, about long time ago state presence. Perhaps long time ago state presence affected prosperity then, and we're capturing the persistent effects of prosperity. We don't think that's the case because there wasn't much investment. Even though the state was there as a repressive tool or as sort of an administrative hub. So there wasn't any of these local investments at the time. For example, Guterres was writing during that thing. And that's why he said there isn't even the state in places. And then we actually showed that historical outcomes around the beginning of the 20th century are indeed not uncorrelated. So this effect emerges later, as it should, given the historical account. So results are the same, where without current highways, you can combine instruments. You can do the same thing with just one instrument, two instruments, three instruments. The results are the same. Of course, they become a little bit less precise. You could do Bramoulet and this combined. You can just use the instruments of your neighbors that are not neighbor. You could do that. You can do spillovers are also on neighbors. So that's one way of going to endogenous effects. One thing that's you can exclude high violence municipalities. And then let me come to these in a second. So one cool thing I can't resist but show. Okay, these are all things I told you. This is the historical outcomes. Actually, some of them are negative, some of them are positive, but insignificant. This is the placebo, slightly positive in 9 cases, but insignificant, except this one, and then insignificant. So the things that shouldn't be affected, in fact, are not affected, and then the externalities are way zero. So this is one thing I wanted to show. Okay, so there's a lot of robustness here. Where did it go? Oh my God. Okay, one thing I wanted to show, and it's not here. Oh, I'm sorry. I was sure it's here. Oh, okay. All right, it's here. This is the one. Okay. So some of you will be very hard-nosed empiricists and will be worried, rightly I would be if I were sitting, that I'm still, all of the things that I have given you, I'm still capturing some sort of background correlation, and if just, Rick appears to have an effect on Ludger because, they are just friends and neighbors and there's some affected. Could be. I can never rule that out. You have to make some identifying assumptions and live by them. You have to stick your neck out. But there's one small test that I can do just to increase the plausibility. As I told you, we have different sets of state agencies. So let me classify them into health agencies, regulation agencies, service, and education. Okay? If there is a real externality, it shouldn't go as much from Klaus's health agencies to Monica's education agencies, but it should be from Klaus's health agency complementary to Monica's health agency and likewise. So that's the regression we do, and that's with the system we estimate. So we free up one at a time. We can't do all of them. So we free up health agencies on other people's health agencies and other people's other agencies. And that's exactly what you find. That it's the colonial states in your agency, not the other ones. And that's the pattern that gets repeated, except for services, which is like an amorphous residual group. It's not significant, it's positive, but not significant, but at least this one is very precisely estimated, etc. And then you never have this others becoming significant. It's always very, very close to 0. So at least it doesn't look like it's some background factors that makes everything move together. The pairs that should move together according to sort of common sense are the ones that move together. All right. So now, since Hans Werner asked, I will take 2 minutes, 3 minutes to talk about national bureaucracy and the national state, and then I will conclude entirely. Okay? So to answer that question, I need to bring the state in. So we do this in 3 layers. First of all, we do we say, let me just take exactly this structure, but control for national bureaucracy. So there are the state employees and national employees. So when you do that, the things don't change. So this coefficient was 0.17, it becomes 0.18. You know, controlling for national changes the fit of the model, but it doesn't change the spillover and the strategic effects. And these are the spillovers. So you remember this number here for not in poverty was around 5, it's now 4.4. So it's not a big difference, and things stay. So then we say, okay, this is just too crude, everything is endogenous. So let me do one other thing. Let me now do this first order conditions of the general model, but still taking bureaucracy as exogenous, national bureaucracy as exogenous. Meaning now I'm just looking at the first order conditions of each municipality, but now in the general nonlinear model. So that's going to give me 3 nonlinear first order conditions. Now I can estimate these with simulated maximum likelihood, or simulated IV, simulated GMM, whichever one you actually we do simulated GMM because convergence is much easier using the same instruments and treating national bureaucracy again as exogenous. Is that a problem? No, because we're building up to the full system, and the full system you condition on the national bureaucracy, so that will be just like treating it as exogenous. So you do that and you get the parameter values. This is the linear model, this is the general model treating. You see it's amazingly similar. So it becomes a little bit more precise, but nothing qualitative changes. So that's, again, now allowing the additional nonlinearity doesn't change anything either. And then the final thing, we now come and say, now let's estimate everything together. But there you need to make more assumptions. Why? Because we have these unobserved weights for the national state. How much does the national state care? And you know, we can't estimate all of these numbers also, so we parameterize them as random effects, as unknown functions of certain historical variables, geographic variables, and network centrality variables. So we have a vector, you allow them to have counters arbitrarily, and then on top of it random effects. So we do that, and it turns out things are pretty similar. So if you do this exercise, remember, we're doing exactly the same thing, going from lower than median to median state capacity for the local state. It went from 57 to 60 before, now it goes a little bit smaller. But if you do the general equilibrium, it again goes from 57 to 67, so it's a big effect.
No, this last answer I don't like.
No, yeah. But I haven't even given you the last answer. No, you one more minute,
okay.
And then I will give you. You asked me what does the state do, and then now we come to that.
Not what does it do, what should it do?
Should it do? So I'm going to answer that also. Yeah. So I'm going to answer that. So if now you change the state without taking into account anything else, it doesn't have a big effect. So this is the national state. But you might think that's not the right answer either, because we're doing a very local change. So now we come to your question, which is, what should the state do? Now we need to take a particularly paternalistic view. The state here does the optimal thing given its weights. But you could change the following. You could ask the following question. Can we change its weights so that the state now cares differentially about different municipalities? And it turns out the state does care differentially about different municipalities, perhaps equalize them, so that we can do a counterfactual experiment of how does the state reallocate, the national state reallocate resources away. And then the answer is big. And that's this. So here, this goes slowly because it's a big file. But we're almost there.
Yeah, this is the constitutional level. Yeah, you think what could be the different weights, what could be the rules of the whole thing, so that a better outcome.
Exactly.
Yeah, this
so
is too one for me. For my mind, this is one level too high.
Okay.
You know, suppose
what was your question? Sorry.
No, I think
this is taking a long time to change.
I have the government of Colombia, and they ask you, Mr. Acemoglu, you have done these wonderful things, telling us about good and bad equilibrium between our communities, and we want to establish a better one. So,
I will
take the paternalistic.
What's your objective view? What's your objective?
Well, suppose we wanted to reduce the poverty line.
Okay, so that's what I'm going to answer.
Yeah.
That's what I'm going to answer.
To stick to this example.
Right, so that's what I'm going to answer.
So what should they do?
The other question you might be asking, this is my utility function. What should I do given my utility function?
No, the state will not ask you that. The government wants to know now. Come down to the earth.
You'll see tomorrow,
don't escape. Don't escape to your model. Now, suppose I'm the government and I want to know what I should do to improve
is reality ignoring political economy?
Well, come on.
No, I'm very serious.
Yeah, talk to this guy in a language which he understands.
No, I absolutely disagree.
Why?
Disagree. So I'm going to answer your question. So it's not a question that I'm evading it, but you are posing the question entirely incorrectly, in my opinion. And it is entirely incorrect because you're posing it as if there is just one right way of thinking about the problem. No, there isn't one right way of thinking about the problem, because if you go to, and this was the whole topic of yesterday's talk, so I'm going to stick to it, with great force, that many of these centralized states, Colombia being a prime example, don't really want to develop the country. Their objective is not to reduce poverty. Right. They have a different objective. So I think you need to have this conversation about, I would like you to do that, so I agree with you, but if you just tell them that and you don't take their incentives into account, they're not going to listen because that's not what they want to do.
Yeah, I know this difficulty. Still, conceptually,
so it's not escaping to my model. I think I'm being consistent.
Well, this is this is in every state the case. I know how politicians act, but still, I would like to know what an isolated perspective is. What could be good for the country? So I do want to have the norm somehow. And whether the politicians in the central state listen to me and implement it, it's a completely different issue. But because if everything is endogenous, why do I do this exercise? Just to know what's happening in this world? No, I want to improve the world.
No, you can. That's why I'm going to give you the answer.
Okay.
That's exactly.
But only on the constitutional level.
No, I mean, I'm going to give you the answer exactly, actually, as you want. But I don't want you to think that that's the right answer, because there is no right answer. So that's why I'm having this debate on you. So I'm not evading it. So in fact, the right way to think about it is that I am changing the weights. But I'm not going to do that because, first of all, mathematically that's more complicated. And second, I don't want you to think that I'm evading you. So I'm doing exactly this. So I'm saying, what can optimally redistribute existing bureaucracy, just the state, take the local government as given. I can't change what they want to do. But as the national state, I can redistribute my functionaries, which I have in the model, around so that I reduce poverty. In fact, I say here, so that I improve the average of the 4 outcomes I'm looking at. But you could do it just for poverty. And then as weights, I use population. So I'm totally exactly, I think, the Hans Werner Sinn utility function. I'm utilitarian. Is that what you want? Yes. Okay, that's the answer I'm giving you. But it's not the right answer. It's just one answer, and you have to very specifically formulate what that is. So that turns out to be not a trivial exercise, because now you take the equilibrium as given, and you solve a game over that equilibrium.
So you say you change the population structure?
No.
What?
No. I change E, which is the redistribution. So look at the screen. I think it'll be easier. So I'm maximizing this, which is the utilitarian social welfare. And to do that, I choose E, which is redistribution. And redistribution is such that whatever I take from one state, I give to another. Or so one municipality, I give to another municipality. So I'm not giving, this is not the US coming and injecting resources. So the Colombian government has the same resources it has. It can rejiggle them around. And subject to, of course, this is the budget constraint. You can rejiggle them. And subject to the equilibrium. Because you now have to take into account how the municipalities respond to that. And this is what happens. You go from the gray to the yellow. Huge. So you are right. If the Colombian government could be convinced to entirely change how it redistributes resources across municipalities, you can cut this tail, or where is this? Sorry. Where is the poverty? This is, okay, this one. So you can entirely cut the municipalities that have more than 40% of population in poverty. Huge. Good luck convincing the Colombian government of that. Tomorrow you'll see that Colombian government was quite happy murdering innocent civilians. So we'll talk about state building.
Yeah, maybe it's time to finish, no? We will continue tomorrow. Thanks a lot for this wonderful second lecture.
Thank you.